Thank you for coming back at our channel, The Physics Mindset, our channel to deliver you electrical installations, electronics, and solar engineering. Now, I want to ask you something small, a question for engineers. If you're a student in electrical, if you're an electrician, technician, or professional engineer, please, even though you're not an engineer, someone there at home, you are at home, check this question. Have you ever wondered where this electricity we are having at our place actually comes from? Have you ever wondered such a question? Have you ever wondered, if you're an electrician, technician, how these power stations produce thousands of megawatts of electrical per second? Such questions, what comes back in your mind? Okay? Our home lights using electricity. Power stations, the transformers, produce megawatts, thousands of them. But where does this electricity come from? What we're going to discover today is the electrical power generation. Electrical power generation. Power, how power is generated. And today you will know how this power comes to reach our homes and power our gadgets and give us light. Okay, let's jump into a definition of electrical power generation. Power generation means generating electricity in simple terms. Okay, check the definition. What is the electrical power generation? Electrical power generation is the process of converting other forms of energy. Converting other forms of energy into electrical energy. That is what we refer to as electrical power generation. We are talking about the generation, how electricity is being generated, so that you can see power at your place. Your TVs, your radios, your microwave, your washing machines, your lights, giving you that power you want. Okay? You just need to switch on. But who generated this power? Where does this power come from? It is what we have started, the generation of electricity. We are going to see step by step how electricity is being generated, by which forms of energy to generate this electricity. Which forms of energy are responsible to generate electricity? Check. Some of the energy, like this, there is a word I'm looking for. Converting other forms of energy into electrical. What do they mean? We mean there are different types of energy outside there. Even electricity is type of energy, electrical energy. Okay? There is heat energy, kinetic energy, potential energy, thermal energy. Check some examples of energy, by the way. We have mechanical energy. These are one of the examples, energies which are converted into electricity. Okay? One of the energy is mechanical energy. We use mechanical energy to produce or to generate electricity. Mechanical how? Check this. In the generator, a use of a generator is to turn the mechanical into electrical. Check. There are very different types of generators outside there. But we have power generators, and we have these generators which we use at home. Okay? Now, these generators which you use at home, they are done manually. You are pulling a mechanic. That turbine to run, to change this mechanical into electrical. Then once the generator starts, it starts and it will give you the output of an AC generation, AC power. Then you plug in your plug and your house will light up. Meaning, You have converted mechanical, you have pulled, and a turbine is being mechanically turned to rotate, to turn the electromagnetic inside the generator to generate power. That is mechanical. Those are generators, okay? We use generators to generate electricity. Number 2 is, by the way, before I jump into number 2 on the example, number 2, this mechanical energy, it is much essential in generating electricity. Check on the power plants, like I'm saying on the dams. We have those those generators which generate power at the dam. Okay, the turbine, the water drives the turbine. The turbine rotates or spins. The moment the turbine spins, this turbine is connected on the generator, meaning a water turns. For example, let me give you a brief example of what generation, hydroelectricity generation, because we are going to talk much on hydroelectricity power, though they are different type of electricity. Okay, but hydroelectricity power is more crucial than other forms, because, like, for example, in African countries we normally use this hydroelectricity power. It's very wide. Okay, check. For hydro, this mechanical, let's talk about the dam, for example. Okay, listen clearly how a dam generates electricity from mechanical to electrical. Now, we get our river flowing. Okay, this is our river. Now, there is a waterfall. Water is fall. Now, this is the rock. Okay, this is the rock. This is the river flowing. When the waterfall, when people see some waterfall, they see some generation of electricity there. That's why most rivers are constructed on a fall, on a waterfall. Okay, now, because of the speed of when the water is falling, there is some gravitation which pulls the water down and comes by with some certain force which can drive a turbine. Check this. Engineers come up and build a dam here at the waterfall. Okay, now this is our dam. Engineers build a dam, and this dam here, there is what we call a reservoir, a water reservoir. They collect water in the very big cham. Okay, now this is the cham. They collect water here. This is now the water at the dam. Engineers have constructed a dam. At this reservoir, they collect water in a big amount. Then at this reservoir, they get a hole which water, there is a gate here which closes for this water to collect. Okay, and if you switch, there is a switch which opens this gate, so that water will flow through this passage. This passage is called the penstock. The penstock, where water is going to fall after from the reservoir. Here from the reservoir, it collects its kinetic energy and potential energy together. The moment they open here, water flowing, there is some gravity, gravity will pull this water in the reservoir and the water will pass. Now, they close here. This is the penstock where water is going to pass with high force, high pressure, plus also the gravitation force pulling that water. Water is coming with its kinetic and potential energy together. Gravity is also helping to pull this water down, so that the water, here, there is after the penstock, they put small thing where they build something and they put a turbine. Let's say this is the turbine now. Okay? Now, this turbine is waiting for the water from the reservoir to come. This water is going to come with a high force together with this potential and kinetic energy together, and the gravity will pull this water. Okay? Turbine is there waiting. This turbine is connected. This turbine is connected in the generator. Now, this is the generator. The generator is having magnets inside, permanent magnet and movable magnet on the turbine, and the coils on the turbine, and this side also we have coils on the permanent magnet. Okay, north and south. Now this is a generator. I'm showing you the dam, the operation which is there at the dam. This is a turbine, water turbine, a turbine. Now, when they switch on, water will flow from a reservoir. You know, it's a small reservoir, though water will be here on top here. These things are done down there, under the dam. Water will be flowing on the top. Water continues flowing at the top, okay? But down there, estimate that these things are constructed down at the dam, okay? Now, when the water is left into the penstock, it will come with force and hit the turbine. The turbine, check, the turbine is mechanically, with the force of the water, will spin with a high force. Okay? Once the turbine spins, it is connected in the generator. Okay? And this generator, it has magnetism and the coils inside. Magnets and coils inside. Remember, in generation of the power at the dam, we use the principle of Michael Faraday's law, Faraday's principle, which is electromagnetic induction. Electromagnetic induction is when two magnets, for example, when two magnets, this is south, okay, let's say south and north. South pulls forces from North Pole. When you place here your cable or a conductor, let's say a copper conductor, copper wire, okay, inside the magnetism, here there is magnetism, okay, pulled by the South Pole, North Pole. Now when you press your cable inside in the magnetic fields and you turn them up, down and up, you will have some voltage here at the cable. Do you know that magnets are responsible in a generation of electricity? This is one of the principles which was found by Michael Faraday with his principle of electromagnetic induction. Electromagnetic induction, the moment this cable is being played up and down in the electromagnetic fields, some induction, some electro induction. That's why it is called electromagnetic induction. Some electro induction will be induced in the cable. Some forces will come inside the cable. This force is what we call the electromotive force, EMF. Okay? This electromotive force, the EMF, will be induced in the cable, and we shall have electromagnetic induction, electromagnetic induction. This was found by a man called Faraday, Michael Faraday. Faraday's principle. Faraday and Joseph Henry, they are the founders that once a magnet is in a south pole and north pole, once you press, you play around with your cable in the magnetic fields, you will find there is some forces which will be induced in the cable. That is the electromotive force, EMF. And once the EMF is induced, there will be electromagnetic induction. And that is the principle of a generator. Faraday discovered the principle of a generator. Now, this turbine, let's come back here. When this turbine is spinned by the force of the water, the turbine will spin around, okay, clockwise. Now, the generator, the coil, this turbine is connected in the generator. Generator is having some magnets inside and the coil. The moment the turbine is moving, is being rotated here by the force of the water, the generator inside here, because there is magnetic fields inside, electromotive force will be induced in the cable, and we shall have an electromagnetic induction in our cables inside, and the generator will produce AC power. Now this AC power, normally this generator produces AC power which is around 10k volts to 30k volts. 10k volts, I mean 10,000 volts. That is very high. That is very high voltage. AC 10,000 volts to 30k, 30,000 volts. Check this. 10,000 volts to 30,000 volts. Something small here. Okay. Yes, I'm giving you a clue about the generation on the dam. What happens at the dam? Let me rub off this so that we complete very well. Okay. Now, this generator will produce 10,000 volts to 30,000 volts. Now, where we want to transfer, that is when we need the transformers to transport this power generated by the generator. That is when you will find this power will go to the transformers. This is a transformer now. Transformer. Remember a transformer. Let me say like this. Remember a transformer or a power station. These transformers, their use is to step up. The use of we have two types of transformers. We have a step down transformer and a step up transformer. Now here at the generation, we normally use a step up transformer, stepping up the voltage from 10k. Let's say from 10k generated by the generator to the transformer, step up transformer. We shall step up this voltage to 100,000 volts. Meaning here, the output of this transformer will be 100 kV. 100,000 from 10,000 to 100,000 volts. 100 and above. Okay? Why do we step up this 10k? It is because we step up because we are going to transmit, or what we call the transmission, whereby now the company responsible for transmitting power from one place to another by these large metallic pylons, okay, they will come in. Now here there is the generation. Now here we are going on the transmission. From transmission we shall go on distribution. Check on the transmission, on the 10k here, that's when you will see these pylons. Okay, hope you have seen something like this. These are cables again another pylon. There's a cable passing. Okay, these cables are 3-phase cables. Okay, even these generators, they produce a 3-phase power. Transformers, they transform, they step up to 10,000 kilovolts, and that's when we get these pylons for that we transport this power for a longer distance. That's why we step up the voltage to higher voltages. Now, from these pylons, again, power goes back to the transformer. Which transformer is now, we need to step down. Another substation. That is when now at your village, you will see a substation somewhere, okay, in a certain area, protected. They install some transformers there, step down transformers. Now this is a step down transformer. Now this step down transformer will step down the 100,000 volts to the power we need. Okay, it may even first step down this power step from 1000 to, let's say, to 415. From 1000 to 415 volts. AC, still AC. Live 1, live 2, live 3. Again, this 415 will be taken to a substation to step down again. Step down transformer to step this 415 volts into the voltage we use at our home. Now this is our house. You see the movement of electricity from the turbine to the generators. From generators, it produces 10K volts. Then from the generator to the step-up transformer, we step up this 10K to 100 voltage. Then we transmit it to the pylons, these higher pylons. Then power goes to the transformer step down. We step it down a bit. This 100,000, we step it down a bit to either 400, either 500 volts. It depends on the transformer we are using, okay, to step down. Then from step down, again, we step it down for our people to use at home, for us to use at home, to light our gadgets, the TVs, the refrigeration, the microwave, the washing machine. By stepping this 415, either 415, these are voltage, high voltage, 3-phase system. Then we step it down on the power we can use inside this transformer. Then the power, the responsibility, the company responsible for distributing of the electricity into our homes, it comes in from this. For now, there are 3 types of companies. There is a company responsible on the dam, responsible for generation. From the reservoir, water goes through the penstock to drive a water turbine. A turbine is connected on a generator. Then a generator generates electricity from mechanical. I was explaining this. From mechanical into electrical. 10K electrical volts. From electrical, transformer. Then we go to a transformer. Transformer steps up to 100 kV and above. It depends which transformer they have used to step up. Then we transmit the power with these high pylons or high poles, electrical poles, to a step down transformer. We try to step down because this is too high voltage. We step up, we step down, then we step down for our home. Now, we have 3 types of companies: generation companies, transmission company, and distribution. Distribution starts from here, after the 3-phase transmission. When it comes here, it is something like 240 volts. It depends on the country. Some countries use 230 volts, okay, for home use. Now, This transmission company stops here. Then distribution companies, the one which are counting our bills at home, okay, they start from this transformer, step down, so that they distribute our power into our houses, the power into our houses, right? Then they can put a meter somewhere so that they can bill you very well. These guys have no play. They can bill you in this meter, and they count how much money you use every month. That is the distribution of power inside our houses. And we are the final consumers. When you switch on and light is being, your TV is working, your cooker, we are the final consumers. We consume by switching on. The moment you switch on, you're consuming. That's why we are the final consumers. But all these people, they will not consume any power. They're just transmitting from one place to another, but different companies. Okay? Yes, I was explaining the mechanical. A turbine changes electrical, a generator changes a mechanical into electrical. Okay? Thermal energy. Also this is also type of energy used to generate electricity. Thermal, that is heat. They burn heat. It want to look like nuclear. They use heat. They use heat to generate electricity. Okay? There is thermal energy, which is heating of, if heating are like fossil gases, so that this thermal, we are talking about the heat. You heat something. Let's say this is we are going to burn something here with high temperatures. Some chemicals, fossil chemicals, it's like chemical energy. It's like also chemical energy. They heat either water so that it turns into high. Then this water is collected in this, they build something like a tube. Then steam comes out with high pressure. They put this high pressure, they make sure that the water is heated to be in position to run the turbine. This is the turbine, whereby the same principle. The turbine, once the heat comes, the heat will move, will knock the turbine, and the turbine will move. Meaning, when the moment this turbine moves, this turbine is connected on the generator. The same principle like hydro, how I've explained to you at the dam. Okay, the generator will make this mechanical into electro, mechanical energy into electro. Okay, but it has used to the steam, the thermal heat, to drive the change. Here we shall have electro. Then from electrical they go to transformers. A step up transformer, then transmission. After transmission, then a step down transformer. Then our homes. This is a step down. This is a step up. The same principle, but using steam to drive a turbine. Remember, at the dam hydro, we used water to drive the turbine. Turbine is used to change mechanical into electrical by use of a generator. The same principle. Okay, now check on the chemical. Chemical energy also is used. You remember, electrical power generation, we said it is the process of converting other forms of energy into electrical energy. Just we are on an introduction of how electricity is being produced or is being generated by changing other forms of energy, and you get electrical energy. First we saw in mechanical, now thermal, now chemical. Also chemical is used to generate electricity. Okay, these are forms of energy which are converted into electrical energy. Chemical energy. Check in chemical energy. a battery. A battery stores chemical energy, right? Now, this chemical energy, again, this is our battery. A battery can also, it stores chemical. Chemical reaction takes place inside the battery. Okay? Now the battery will change into electrical energy. From chemical into electrical, positive, negative. Once you tap here your inverter, the inverter will change from DC to AC, meaning we shall have electricity here at the inverter. Meaning a battery, chemical energy also is used to change from chemical into electrical. These are just forms of energy used to try to change from their form of energy into electrical energy, and that is what we are talking about today. Okay? Now, solar energy. Solar energy also is a form of energy which we use to generate electricity. Check the solar panels. From solar heat, photovoltaic effect, which will heat will hit the panel. This is the panel. Heat will come and heat. This is heat or sun rays. Will hit the panel. This is solar panel. Okay? Solar panel. Then this solar panel, because of inside here, there is some effect which is called the photovoltaic effect. The PV, photovoltaic effect. Photovoltaic, meaning a photo and the voltage. A photo is the sun. The sun makes a photo on the panel. Then the panel will change this photo into a voltage. That's why we get that into a photovoltaic effect in solar system. Then the solar panel will produce some electricity here. Meaning from a solar into a photovoltaic effect, then we shall have some electricity generated by use of a solar panel. Okay, this is also a solar energy type which we use to generate electricity. Check another part. This is wind energy. Wind energy also is, we use it to generate electricity. Without wind, sometimes this technology, technology is wide, electricity is wide. Okay, we use the wind to generate electricity. How? That wind you see in the atmosphere, we use a wind energy. Once a wind is moving, we get some wind turbines. Let's say this is the wind turbines, very big turbines. Okay, this is a pole, but this pole inside here, this is where we put our generators. Now, when the wind comes, the wind will knock this turbine, and turbine will spin. Okay, the moment the turbine spins, they don't spin very fast. They spin slowly. But the moment they spin, this spin which you see slowly, it's changing. The turbine is connected on the generator, whereby the generator, it is changing mechanical into electrical. The same principle. Okay? Now, these turbines, they move and they are connected to the generator down, and the generator will produce electricity. It's a form of energy used to generate electricity. Okay? Nucleus is the same principle with the thermal energy. Okay? Now, this is the forms of energy which we use to generate electricity. Okay? Forms of energy we use to generate electricity. Because we said the generation of electricity is converting other form electrical energy. Now, Why do we generate electricity? For what purpose? For what reason? Can someone ask himself or herself a question like that? Why do we generate? Why do engineers generate electricity? There is a very big impact in our life without electricity. Test one day or 2 days when you don't have electricity. The use why they generate electricity is to power our homes. One of the use why we generate electricity to power our homes, our lights, TVs, charging our phones, powering our washing machines, microwave. Another reason why we generate electricity is to power the industries. Industries operate on electricity. 3-phase system, 2-phase system, single-phase system, so that we can produce things like this cloth produced from the factory, from the industry, the factories, okay? Food processing plants, they use power. That's why we generate electricity, okay? You see how the useful of generating electricity, it makes our life to move on. Check. Also, they generate electricity to power hospitals. To power hospitals, in which way? Without electricity, hospitals cannot be in position to run their life-saving machines. People operate on electricity. A lot of people in hospitals live by use of testing their life using the life-saving machines to say that this one is about to die. This one life is coming back. They're operating on oxygen. All machines are on electricity. Okay? Check another use. At schools, electricity is used to power our schools. Do you love your kids to read books at night? So, without electricity, how can our children read books at night? Okay? The computers to print exams, to print the books they are reading. Use of electricity, generating power. It's so much essential in our day-to-day lifestyle. Check on the transport system. On transportation. Transport system. Without electricity generated, transport will have some difficulties. Check on the chemical. If we talk about chemical energy, that is converting the battery from chemical into mechanical. That is driving, like in a car. Cars use battery to start driving. Without a battery, a car can't move. You see, a car to start with the key, that is turning some electrical from chemical, then you switch on your car with the use of a key. And the car will start by use of electricity produced from the chemical energy from the battery. Check some of the European countries. They use these very high speed moving trains. Okay? And these speed moving trains, they use something like 20 to 27 volts or 20 kV, 20,000 volts. Those trains you see, those electric trains, they use 20,000 volts. So without electricity generated, these trains can't move, okay? Now, another use of generating this power is like in communication systems. Like in communication, it helps us in communication. Our phones operate with use of electricity. There is a battery inside our phones. Okay? Communication networks, they need the generators to produce that power. The power which is used to boost the network into your phone. because when the generator is not working, once a generator, remember the principle of generator, we said it is Faraday's principle of electromagnetic induction, producing electricity in the cable. Now, without those generators to boost these power communication plants, so that we can get the network we have at our phones, okay? Power without electricity, this communication system will die off. Our phone, charging our phones without electricity, our phone, after 3 days, the phone is off. You will see life complicated without a phone, okay? Now, generating of electricity is so much essential in our day-to-day life. And we thank those engineers who are doing the great work of generation of this electricity, okay? Now, we are going to go through the types of electrical generation. In today's video, I was just introducing the way this power, this electricity is being generated. And some forms of, because it is generated through a process of converting some forms into electrical. And we have been seeing some forms of energy: mechanical, thermal energy, chemical energy, solar energy, wind energy, nuclear energy. These are types of energies which we convert them in some process so that we get electrical energy. Now we shall go one by one and we study how this mechanical is used to produce electricity, how the thermal is used to produce the electricity, how chemical is used, how wind, how solar, how nuclear is used, so that you know the fundamentals of the generation of electricity. Once you know the generation of electricity, it will boost your understanding of the fundamentals. Okay? You will know where the electricity started. It is very much important to have knowledge where something started than having knowledge when it is already done. It is very good as a technician, as an engineer, to have this in mind, that electricity is generated like this, like this, like this. The power we get is from here, from here, from here. Okay? Now it will be easy for you for anything to troubleshoot in electrical. Anything they can call you, come, you can work on the generation part, you know the knowledge. You can apply to go and work at the dams, you have the knowledge with you. You can, as a technician, okay, engineer, electrician. As a student, after finishing, you have the knowledge of the generation. Go and apply to the dams, those companies. They'll give you some knowledge, some questions, and the interview, you will pass them. Okay? If you have the knowledge on transmission, you will go to the transmission companies and apply there. Get some jobs there. Without the knowledge of transmission, they can't give you. It means you don't know electricity. Go to the distribution companies, the one which put the meters for us so that they bill us properly. Once you have the knowledge of distribution, you have the knowledge of transmission, generation, they'll give you a chance and you work with them. We are not having this. Someone can say, why are we having this? This is to prepare you for tomorrow. Tomorrow's generation, we need you. A student who is studying engineering, electrician already in the field, and they already engineers already who are working, but some have no knowledge about these fundamentals. And once you know the fundamentals, everything will come to ease. Every wiring you will be capable of doing anything in electrical. Electrical is very wide, and we shall see the projects in electrical. The moment you know the fundamentals, all projects will be, you will be free to operate in every project, because some projects need this knowledge of the fundamentals, the generation. And once you know the generation, you'll be able to know the distribution. It will give you the basics of any electrical problem solving. Technically, you will have the knowledge. Trust me. Thank you for watching. See you in the next video, which will be about the types of power stations. The types of power stations where electricity is being produced or is being generated. Those power stations, we are going to discuss them. Don't try to miss. Subscribe, thumb on the notification bell, and don't miss any video. Trust me, you will have what you need. Thank you. See you in the next video.